There's the one part I forgot at micro, to press that little red dot. Okay, and Kaylin's on too. Wow, we got a whole big crew. All right, so get this thing going. So we're gonna start off with questions over the homework. So pull up your stuff. Yes, Jameson.
Can you do chapter 4, apply number 1?
Apply number 1?
Yeah.
Chapter 4, apply number 1. Okay, we got some product testing. Okay, product testing. Let's see if this thing can focus. Just need to track which one's focused on this thing. Come on. There's that. Light. Light. Oh, get closer. All right, there we go. Product testing. Total cost of product testing is 60 plus 10Q, where Q is the number of products tested. The price of product test equals the average cost per test. And each corporation in a region purchases one product test per year from a product testing firm in that same city. All other inputs are ubiquitous, available at the same price at all locations. Suppose 5 corporations are initially distributed uniformly with one corporation at each city, A, B, C, and D. Is the initial distribution a Nash equilibrium tested with a unilateral deviation? Was it A or B that you were wanting to cover, or both?
A.
A, okay. So who's got that one? Feels pretty good about their deal. So what was the answer first?
Not stable, Nash equilibrium.
Not stable. Okay, so it's not a Nash equilibrium, the initial distribution. And so whenever it's not stable, then that means you should be able to show that there is a move that will make at least one party better off without making the other worse off. So, what'd you guys get? Jonathan?
I guess I just said they would all start moving closer and start to cluster and see.
Okay, so, and why is that?
Because it's kind of like that ice cream on the beach thing.
Okay.
Like the firm in A moves to B, it can take half of B's customers and still have all of A.
Okay. All right, other people?
Yeah, I was going to say that there's only 5 product tests being done, and he can go in and take most of them and most of the profit if he lowers the price to 40.
Okay. How would you be lowering the price? Did you just say lower the price?
Yeah, if he wanted to take the other customers.
Okay, so what happens if you do get more? What happens to your cost? So 5 corporations initially distributed uniformly. Did anybody do a picture, like kind of a uniform distribution, little picture like we did? Didn't do a picture?
I had formulas and started like a graph.
So are they picking up another test then? Each corporation's in a region purchases one product test per year from a product testing firm in the same city. So how does it become more profitable, or why, I want to think about why they would move. Is there enough information here to think about why they would move? So Kaylin, Jacob, Tyler, what do you guys have to say on this one?
I can show you how I found the price.
What's that?
Actually, the price was $22. I can show you.
Okay.
On that.
How'd you get 22?
So I set the 60 plus 10Q, the total cost equal to the total revenue, which is just price times quantity.
Right, because they said it's a normal profit, which is one of our assumptions. So whatever the cost here and the number of units, then we'd be able to figure that out, okay?
And I put the quantity at 5. It was only 5 total tests being sold. If he can get all of them, that's what the price would drop to, is 22.
Okay. So the lowest it could be would be 22. With basically just taking that average cost. I mean, we could do the average, in fact, we're gonna do that today. So the average cost function, what do we do with that C of Q function? To make this the average cost.
Total cost over quantity, right?
Yeah, over quantity. So then it's 60 over Q plus 10 is the average cost function per unit. So now the more you make, you just did the 5 in here, right? So 60 divided by 5 gives you 12. 12 plus 10 is 22. And if you had 4, then it would be a little bit different, right? So each one would give you incentive to move. Okay. Anything else on that one? And then I guess you said you were described the Nash Equilibrium in terms of the distribution of firms and the price of the product test. So then for this one, the answer was what?
Deviation decreases price from 70 to 40.
From
All-
70 to 40?
All of them would cluster and the price is 22.
Okay, and the price is 22. Okay. Any other ones?
Did you do apply 3 on chapter 4?
Yep. Risk neutrality?
Yeah, I just wanted to.
All right, consider the model for labor pooling as shown in 4.2. Suppose the next generation of workers is risk neutral rather than risk averse with the utility function W minus S. For the isolation site, the wage is 144, the switching cost is 44. The switching cost is 0 for jobs in the cluster. How does the change to risk neutrality affect the advantage of larger cities in labor pooling? So what did the answer have?
CE equals 122.
CE equals 122, so it gave you the certainty equivalent. Okay? Sounds like you had a little bit of work here. I did talk about, remember when I brought this up with risk neutral versus risk averse?
So I just wanted to make sure what I did was right.
What'd you put?
So for the wage, I put, or that equation it has for us, for the wage, I put the 144 minus 0.5, the 50% chance times $44, the switching cost.
So what does the utility of income line look like with this?
It's gonna be,
Because the other one looked like this, right? We did the 144 and what was it, 100? And then we had the 10 and the 12 and 11, and then that was 121, right? That was the old one. That's the one we did. That's the risk neutral, or that's the risk averse utility line. Whenever it's concave like this, when it's going up at a diminishing pace, then we have that. So what does this one look like? Carlos?
Like more like this. I don't know how to.
Straight line,
Yeah.
right? It's a straight line. So here, we end up getting a straight line with the 122. So the average between the two is 122. So if you do a straight line from here to here on this line segment, then you could find the 122 and the WS. That's how this one, you didn't have to go that far with that, but that's part of what's going on with it. So now, what did you guys put then for the implications? Go ahead, Carlos, you have
I just wanna know, like you say how he said it, but what the S means. I know the W is wage, but what the S
Switching cost.
the switching cost, yeah, that was the switching cost. So the switching cost before was the $44 is why we got 50% chance of getting a 144 and a 50% chance of getting 100. So how does this change the risk neutrality, affect the advantage to larger cities relative to labor pooling? Jonathan?
Since there's 0% chance of them getting fired, certainty equivalent, they can lower the wage down to 122 because it's like ranked between them.
What could they lower it to before?
The wage would stay the same, but the switching cost would make it 100.
So with certainty though, they could offer how much? That was part of this whole story. It's one of these numbers up here. So the story was, remember, 50% chance of getting this, or, so everybody gets this at first, and then some people get fired, right? And then you have to switch, which gives you a 50% chance of getting this. Now, when we had consumers at 11 and the ability to do 122, what was our result for the wage of the pooled, of the agglomeration? 100. What would people be willing to take? 120.
3.
So let's back up. We got utility over here. 144 bucks gives me 12 units of happiness. 100 bucks gives me 10 units of happiness. I've got a 50-50 shot of having those, which means my expected utility is 11. But that's an uncertain utility, right? But that's my expected utility of 11. So then the question becomes, well, what would be the certainty equivalent? Instead of a risky 144 or 100, what about a sure deal? What's the sure deal that's the certainty equivalent? 121. Now, that's where the advantage lies with the company. The company has a 50-50 shot of this thing working too, right? And so now, they had an advantage of paying 121. Now, technically, the company has this risk profile of 122. So all we've done is we've made it not quite as good of a deal for the companies now, because they're going to have to pay 122 certainty equivalent instead of 121. And that benefit was actually going to the company before because people were risk averse. And so it kind of made a win-win situation. They're risk averse anyway, right? And so they got the certainty equivalent. But in reality, the utility of 11 is guaranteed, so there was a benefit to them. Okay, anything else on that one? So that was kind of the answer here. How does this change the risk neutrality, the advantage of larger cities? Does it weaken it or strengthen it? Does the change to risk neutrality affect the advantage of larger cities? Do larger cities have a bigger advantage for the company or a smaller advantage? Smaller, because now it's 122. Now another way to think about it is if we got more, think about if we got more risk averse. Here's a more risk averse line. Now at 11, I only have to pay these workers 110, right? So So the curviness is the risk neutrality part. That's their utility function, is their preferences for risk. And so the more curvy it is, then it works to the advantage of labor pooling and to the companies that there's going to be more incentive to cluster. And here it works the opposite. Okay. Other ones on chapter 4.
Number 5.
Number 5. Consider a matching model in a spatial context. Workers are uniformly distributed along the roadway. Each firm chooses an address along the roadway unit length and hires, so that's a unit length of 1, right? It's always between 0 and 1, and hires 2 workers. The cost of commuting is incorporated into the market wage. So the wage equals 50 plus 60D, where D is the distance from the worker to the nearest firm. All right, so illustrate the determination of the wage in a city with 4 workers, 2 firms, so kind of what we did before. Is it part A that you wanted to
Both.
review or both?
Yeah, that's what confused.
Okay, so what you guys got for this one? Jonathan?
I just used the equation that they gave us, so I did 50 plus 60, and then the distance from the worker to the firm is gonna be 1/6 for the first one.
Okay, let me see your paper. I won't have you come up at this point. I'll see if I can talk you through. So this was number 5. Okay, so we're on this one, right?
Yep.
Okay, so now walk us through what you did here.
I just plugged in the equation, which was 50 plus 60 times the distance.
Okay.
And the distance on the first one with 4 workers and 2 firms is going to be 1/6 from the worker to the firm. So if you do 50 plus 60 times 1/6, you come with 60 per worker.
60 per worker.
Yep.
And that was the answer?
Yep. For the
Is what the answer
4
key had
workers.
60?
Yeah, and then for the 6 workers, the distance changes to 1/10. So 50 plus 60 times 1/10 is going to equal 56.
Okay.
And I don't know how they got 62 for the,
And how they got what?
how they got 62
For the last one?
yeah, it's like 6 workers for the,
Was that for part B?
yeah.
Suppose the industry experiences an increase in economies of scale. Well, let's start with part A first. So questions on that? Did other people approach it differently, or did anybody draw a picture or anything? Zeke, what'd you do?
I just drew the pictures like.
Okay, I'd like to see your picture.
Yeah,
Let's share that with everybody.
It's just like.
Yeah, even if it's wrong or whatever, so that's, sometimes it's good to help your brain reason through it this way. So this was basically the picture from the notes, right? But now you can start thinking in terms of,
The bottom one's for part B.
that was the part B, okay.
So that's what I thought was happening, since they're further distance, those 2 workers are gonna get
And I
paid
can
more.
Yeah.
And so,
So the workers, remember, their little equation to themselves is that they're doing a cost-benefit analysis. Like, I'm not gonna drive, I have to be paid at least this, otherwise I go work somewhere else, right? So that's kind of a little bit strange with it. So what did you end up getting for an answer? Did you figure out the 62? You said the answer key said 62?
Yep.
And did you get that?
I did.
I see some scribbles, so I'm not sure. You did it, Lawson? Okay.
With the equation, how did you do the 62? Because I do it with my calculator, like 50 plus 60 times 1/6, and give me a 19. So I don't know if I don't know how to do this.
What was it, 50 plus 60
Yeah.
50 plus 60.
is 110 divided by 6?
1/6.
No,
Because the
times
distance-
Or divided by 6, times 1/6, divided by 6. And then it equals,
I divided by 6.
yeah, because it's 1/6. Let me see, oh, you got yours on your laptop?
Yeah, I have some.
110.
That's fine.
Still.
See if it picks it up. So you got the 62.
I accidentally put a multiply instead of an add
I don't know.
on that equation.
Okay, here's Lawson's.
Tell me, please.
So walk us through what you did.
So at the very bottom, there's 2 firms at 1/5 and 3/5 because they're evenly distributed, 5 of them.
Right.
So the furthest distance from a firm is going to be 1/5. You take the wage of 50 plus 60 times that 1/5 distance to get 62.
Okay. So with the two firms, the distances changes with the 1/5, 2/5, 3/5, so the unit breakdown here. And then there's a 1 over here to be complete, right? So it's
Oh,
five,
yeah.
5/5 is over here, just to put it on the full scale. So 50 plus 60, right?
Yeah, I accidentally put that.
Okay, yeah, I see the little dot there, so. Okay, questions? So then you basically did the same thing for each one of these, 56, 50 plus 60. Okay.
Can we do the review 3?
Yeah, I want to, let's see,
Check out
60.
I think
When you guys were doing the 50 plus 60, it was 60 times the distance was 1/6, right? Okay, just want to make sure it was, when I saw some of, one of the ones I was looking at, I can't remember
Can you-
if you had the,
Use, like, do that equation real quick, because I don't know why I don't get it.
so the distance ended up being 1/6, so 50 plus 60 times 1/6.
Yeah.
60 divided by 1/6 is 10 equals 60. And then the other one was 1/5, so 50 plus 60 divided by 5, or 1/5, gives you 12. So 50 plus 12 equals 62. Everybody cool?
Yeah.
All right, any other ones on this?
You use 7.
Yep. Consider corporations that use advertising firms to develop marketing campaigns. The marketing cost per firm is M over 120 divided by N, and the labor cost per firm is 30 times N, where N's the number of corporations. Total revenue is 300, and profit is that equation, R minus M minus L. All right, illustrate the determination for the Nash Equilibrium, including the values for the number of firms and the profit per firm. Okay, what do you guys do here? Let me go online. I want to hear what you guys did. Did you guys do this problem? Jacob's giving a shaky. And if you have it pulled up on your blackboard, then we could do a screen share, actually. But one of you unmute. We could go to the random number generator if we want, or if one of you want to volunteer. Let's see, Lawson, number between 3 and 7.
6.
1, 2, 3, 4, 5, 6. Tyler, you're the lucky one.
Alright, so the way I see this is that it gives you, okay, I assume that we're trying to find profit 0 just because that's when the firms are going to be
Yes,
even.
there'd be
So-
incentive. Yeah, that's correct. So if profits are positive, then there'd be an incentive for other firms to enter, right? So you're absolutely right. That's a good assumption.
And then, so using that, it was 0 equals 300 minus M, and then you just plug in 120 divided by N for M minus the 30 times N.
So you basically just set this equation equal to 0, right?
Yeah, exactly.
And then solve for the
Solve for
N,
N.
the number of corporations.
Yeah.
Okay?
And then That's pretty much where I got lost.
Okay.
That was right after that.
Fair enough. So including the values for the number of firms and profit per firm. You got the profit per firm though?
Yeah, the 150.
Okay. So that pretty much answered A though.
Right.
So B, illustrate the determination of the Pareto efficient outcome, including values for the number of firms and profit per firm. So what did the answer key have for that?
2 firms, 180.
2 firms, 180. Okay. And where'd that come from? What did you guys do for that one? And what Tyler did for part B was, and what the answer key had was, it was how many firms? The profit was 150 for 4 firms. So that was part A. And then the answer anyway for B is 180 worth of profit with N equal to 2. Where'd that come from? Kaylin, how did you approach this one?
I can show you how
I don't want to ignore my zoomers here.
Okay, so I did the same thing with the 0 plug and everything, and I couldn't figure out how to get it in, and I didn't have any idea how to do B either.
Okay. What'd you guys have? Did I hear somebody talking over here? Awesome.
So what I did is for A and B, I just plugged in numbers 1 through 5, like for number of firms.
Okay, that's another approach, a little plug and chug method.
And yeah, I used that to find the marginal cost and the marginal benefit, and I set them equal to each other to get firms at 4, and then Pareto improvement would be firms at 2 because total profit goes up to 180 from 150.
Okay, so total profit for what?
All firms?
For both firms? One firm jointly?
And it should be divided by 2.
So it would be 90 for each
Yeah.
firm.
90 per firm?
Yeah.
Whereas here we had what per firm?
Some kind of number.
75.
75?
No, 37.5.
Ah, it's over here.
37.5.
37.
So if there was basically profit on the table to reduce the number, we'd start having mergers or something, right? Is the move. And so, yeah, doing a little table would be fine. So what was the, what you said you did the marginal benefit, marginal cost?
Mm-hmm.
What did that look like? Or you got it on your computer?
Yeah, I should have written it out a little bit more, but I can explain it.
Okay.
So the things I have in the boxes are the marginal costs and marginal benefit. On the L and the M are the marginal costs, and you can see how it goes from 130 to a 150 in the total expenses.
Mm-hmm.
That's a 20 as the marginal cost, and you can see the 170 to 150 is also 20 for benefit.
Okay. So here you're talking about the benefit and cost
Yeah.
ratio?
And it would be like negative 150 equals negative 150, so you could multiply by negative 1.
So you just went with whichever one had the highest profit?
For B, yeah.
Yeah, okay.
Yep. Okay, so I think any last questions on that? That makes sense? doing a little table, working it out. These are probably things that you guys could go back and on your own to do to practice for the test. So our midterm test is going to have questions just like these. So you're on your own to be, like when we're doing these review sessions, you should be jotting notes to yourself of how to do it and maybe clean up. If you did it, whatever you wrote on before, it'd be good to bring that to class and you can make little side notes and stuff and add to it. Feel free to, of course, write down what other students did and stuff I do on the board if you want, or whatever is relevant. It's all for you. Okay, so I think that was it for this one, all right? So chapter 5.
Can we get one more on chapter 4?
Yeah,
Okay.
I thought we did them, but
The review.
Oh, one of the reviews? Sure.
Yeah.
Which one?
3.
3. Suppose the wage offered by an isolated form is 64 and there's a 50% chance of being fired. The switching cost is 28 and the utility function is what we did before. The expected utility for a job with the isolated firm. And so this is basically working through the whole problem.
Yep.
Okay.
I feel like it's wrong. The answer key was wrong on this one.
Yeah,
Did other people think the answer key was wrong?
I thought so.
Or did you force it to be right? That's the thing. You should be able to work it through and prove it to yourself. So did you work it the way you thought it should be worked?
I mean, I did.
That's
I
chapter
just used
5,
my
right?
words.
No, this is chapter 4. This is the review, though. The review questions, not the apply.
I didn't use some big equation, but I said that the original wage, it says, was $64.
Okay.
And
was right.
the switching cost is 28, which 64 minus 28 is going to be 36, and the square root of 36 is 6, not 7 for utility. The answer key says 7.
Oh,
For me, I was right.
you got.
7.
Okay, let me.
You got 6.
Can I see yours?
Yeah.
Yeah, me too.
I also got 7.
And you also got 7. Okay. So let's see if you guys agree with Carlos here. So it was 64, and then the switching cost was 36, right? So what you guys probably did is it's easy to like do the 50% thing here and not here, right? So you got to go in the right order. So the expected utility is a 50-50 shot. Between 8 and 6 is 7. Now you go back to the utility function and do your square root stuff, and yes, 49 would be the right certainty equivalent. And then you've got it. Okay, any other further questions on that? So now here's the beauty of it. If you did your work and you showed your thing, you're not going to lose any points as long as you did think about it. And now you can get it right. So take the time, be brave to be wrong, and then when we do these reviews, we'll just go over it anyway, right? So get something down though. I want to see that you, that's why I have the due dates when we have them, is I want to see that you did put some work into it and that you tried something. Okay. All right, so now that's all of the questions, I think, right? Oh, no, not necessarily, if there's other review ones. Anybody else? Anything chapter 4? Going, gone.
Do you care if I take a second on my phone to turn in chapter 5 because I missed it?
No, just do it later. It's too late now anyway. That's why I do it when it's due, so yeah. You're gonna, it's late whether you do it right now
Well, I just
or...
wanted to do it so I could see it
a
on
week.
here because I accidentally left it in my book back home.
Oh, nah, just do it. You'll be fine. I gotta have you impose some cost, then you will not do that again, right? All right, any of these? 1 through 5. Ice cream vendors?
Yeah.
On apply? Okay, 2 ice cream vendors compete for customers who are uniformly distributed at 20 per kilometer along a 12-kilometer beach. And each consumer buys 1 unit of ice cream per day, and each customer generates a profit of 3. The initial location are vendor L at X equals 3 and vendor R at X equals 9. Is the initial set 3 and 9 a Nash equilibrium? Okay, who's got this one that I can throw on the board?
Can't throw it on the board because I just use words.
You just use word. Did you got a picture, Z?
Yeah,
Okay, cool. Let's look at your picture.
It's just like the
Okay. Yeah, I encourage you all to write a picture because I might force you to make a picture on the test. So the test is not going to be exactly this, but for you to show me your work, I'd encourage you, if a picture seems relevant, this would be a good time to kind of get used to it. All right, so there's our beach through 12. You got it at 9, you got it at 3. The middle is 6. So what's your answer then?
The Nash equilibrium will be at 6.
Be at 6?
Because if vendor 1 moves to 6, then they're going to be able to get the people all from the middle. And so when they both meet in the middle, and everyone from 0 and 12 will meet in the middle.
Okay. Anybody else, something different?
I used to know about 8. Because that was the
You thought 8 would be the best place, or?
No. There's questions, question and question.
Oh, as far as addressing the questions. So is it a Nash equilibrium demonstrated with a unilateral deviation? So did you do a unilateral deviation? What does it mean by a unilateral deviation? So, Zeke, it doesn't look like you did that. You kind of explained the overall outcome.
Yeah, I think that's more B. I drew
That's
something.
the illustration.
Well, let's just talk in general. What is the author, because we've seen this in some other ones, a unilateral deviation.
Just when one part of it moves.
Yeah, just one part. So when we first looked at the ice cream thing, we said, well, what if this vendor moves from here? You could go to here, and that would be bad, right? We kind of analyzed that. But if you go from here to here, you can look at the benefit. And then what this guy's doing, of course, is going to steal one of the guys that was on the fringes here is now going to come to him, right? And so then that you'd show that that's a profitable move, that unilateral, so it's not both moving, right? Una meaning one, unilateral move. This guy chooses to move to position 8. And then assuming this guy stays constant, which is what we do with our economic models, what would be the benefit? It turned out he would gain. Well, then what would this guy do? He'd want to respond by doing that. Is that still a Nash equilibrium? No, because there's a gain for him to move again. And there's a gain for him to move again. And then blah, 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 and you end up, then you can kind of jump to your conclusion. So you know, to fully answer something like that, maybe say, you know, one vendor moves, kind of analyze it, and then say the other vendor would have these same incentives, and the Nash equilibrium we'd predict would be 6, something like that. Okay? All right, so back to what this one says, illustrate the Nash equilibrium. Okay. And that's kind of where we end up jumping.
I kind of like meant like what you're saying with the arrows, because move them one at a time. But I guess I should.
Yeah, so a great thing to do, this is just good general advice. You're done, you're like, oh, finally I solved it. Yeah, you know, you're kind of giving that little Chiefs win, I win, spatial economics loses. Yeah, I got it. Do a little dance, but then come back one last time, read the question, what it's asking, look at what you wrote, and say, did I answer it? That's usually the best thing to do. And you know, is Russ going to be able to read this and see that I answered the question fully? Okay, so everybody's good on this one, or anything else? Okay, other questions on chapter 5? If you guys got them and they're straightforward, we're cool.
Yeah, these ones were easy.
I like
These were
fine.
easier, yeah.
Yeah.
Some of the chapters will be easier than some of the other ones. Some of the models are just a little more intuitive. Some of them are a little counterintuitive. The ones you guys went are the ones we always go over, the number of firms and moving around.
And these ones were just monetary weight, which is pretty easy.
Yeah, if it was just monetary weight, we can kind of figure out where we're going to go. All right, you guys good on Zoom? Thumbs up if so. Okay, I didn't see a thumbs up from Tyler. Okay, thumbs up. All right, so that is chapter 4 and 5. So now, this next chapter is fairly short, and the models are kind of just there, but the intuition is good. So, yeah.
When is chapter 6?
Yeah, we started.
Chapter 6 we'll have due on Thursday.
This Thursday.
Yep. So that way we can talk about them on Friday, and before we go into the weekend with the
Yeah,
rest.
some Blackboard shows like February.
Oh,
Yeah.
oh, that's probably got the old dates then. Okay.
Yeah, it's like all dispersed. Like
Okay. Yeah, I'll maybe get in there and reset them, but what I'm doing is, maybe you guys have noticed, it's the old edition of the book that I'm gonna try to make nicer, but, so I'll send out announcements and stuff that I say in class with the timing. I'll try to do that a little bit more in the future, but otherwise, always ask me or send an email if you have any questions, so.
And what about chapter 2 on the Triumph book? What are we doing that one?
That was tomorrow.
That's due tomorrow?
So due tonight. What I do, I just do before class, as long as you post your bullets before class tomorrow. Okay, so I can't remember if did I do the due date on that one? I thought I did. In the Blackboard due date on the discussion part. Okay,
So,
I'll try to get that posted here too. All right, so we left off last time talking about monopolistic competition. And so we just did kind of a quick review. So this chapter is going to use some of the monopolistic competition to see where do firms locate and how do cities develop, and look at consumer cities, thinking about the consumer and the demand, not just the cost. Okay, so here's where we left off with monopolistic competition. It's a competitive market, so we still have the zero profit thing that we utilized in the last thing. We assume that firms are just going to earn a normal profit in the long run because there's no barriers to entry. So you want to start up. If something's profitable, somebody's going to come in and do it. And then this product differentiation ends up giving us the downward sloping demand curve, where I left off last time that we'd expect it to be probably pretty flat, but still downward sloping because there is a number of substitutes. Okay, so now we're going to use what you guys did in that last problem, average cost and total cost. So there's a total cost equation. Cost, remember how this reads mathematically. Cost is a function of quantity, so in the brackets tells you the argument. So my total cost of production is a function of quantity being changed as the variable, as the choice variable. And it's equal to K, which is just some fixed amount, the setup cost, plus C times Q, where C is the marginal cost per unit. So if it's, I make 5 of them, so $5 times 10, 5 times 10 is 50. And then I had to set up my company for 100. So I had $100 worth of basically the fixed cost of K, and then the marginal cost. So whenever we have something like this, what's going to be the look of the average cost function? Where there's a setup cost, and then there's a per unit cost. And it might be good to take 2 chunks there, but that's a good challenge question. Maybe we should start with what does the marginal cost curve look like graphically?
The Nike sign.
The Nike sign. Okay, so now that is the generic one that we use in principles class, right? And the Nike sign comes because we think that there's possibly increasing returns due to specialization if we have more of a resource added. This is for hamburgers. And so now we got Russ on the production line. We add an identical Russ. We keep adding Russes, and eventually it gets so crowded I'm having to pay Russ $10 an hour, so those last hamburgers get pretty expensive. So this is the kind of theoretical, full-blown marginal cost curve. That is not what this one is, though. For these models, Andrew, it's just a straight line. So the marginal cost curve for this model is equal to C. The production cost is 5 per unit. So if I do 5 per unit times 10 units, 5 times 10 is 50. So the cost per unit as I increase Q, I'm going to use little q since they're using little q. So the marginal cost curve looks like that. It's flat. At what level? At C per unit. All right, what does this sucker look like then? K over Q. Remember, that's the average. So this is the total cost function. I had setup cost, and then for each unit I produce, I had marginal cost of C. So what do we call this part when we think about the total cost equation? Total cost equals, what's this and what's this part from principles class? We're kind of applying it a little differently. It's setup cost according to this. What is K and what is CQ?
Fixed cost and variable cost.
Good, Jacob. So fixed cost and variable cost, right? So the fixed part of the equation is the K, which was the setup cost, and the variable cost is the number of units. It varies according to the number of units I make. So this is really total cost equals total fixed cost plus total variable cost. And then this is average total cost equals average variable cost plus average fixed cost. So back to my question, what does this sucker look like? We just did this sucker. This sucker was this sucker. What does this sucker look like? K over Q.
Shouldn't it be like approaching the bottom line? If you're
Yes.
straight down and approaching it.
So K is a fixed cost. So you might remember from principles class, I'll give you a quickie here. Total fixed cost looks like that. 1 unit, 2 units, 3 units, 1 unit, 2 units, 3 units, $100 of setup costs. Well, 1 unit, the average fixed cost is 100. 2 units, bam, 50. 3 units, bam, 333. And so it goes whoop, right? So it looks something like that. So now we're adding them together. If we looked at the average total cost, and so we could do it this way and say, okay, at 3 units, it was this. What was my variable cost, though? Sorry, I'm extending this little, I'm just doing this off the cuff, but let's do 2 units. So the fixed cost part was K, 100 divided by 2. What's the variable part? What's the variable part? So
Of the
average total cost equals average fixed cost plus
cost.
average variable cost, which is just fixed at C, and C might be, I was just making up a number, $5. So at 3, what happens to my average cost? At 2, sorry, at 2. What's my average total cost?
65.
55, right? And here it would be 33.3
38.
plus 5, plus 5, plus 5. So this sucker would just be looking like this. Now this is, the reason I bring this up, and I'm glad Jacob brought up, the Nike here, because the average total cost curve normally looks like this. It goes down, but then it comes up. That's the real life one, but this one you need some squares in the argument. So again, for simplicity, the author's just throwing at us, suppose we have this simplistic function. Okay, questions or comments there? All right, so this is the monopoly graph, which is very similar to what we did before. So the one thing to remember is when you draw these, if this is the demand curve comes down to here. The marginal revenue curve is twice as steep. So if you take a bisection of the horizontal axis, just to eyeball it, it goes there, drawing your marginal revenue. So that is just the normal principles monopoly model there, right? All right, so marginal cost would be here at C. And so how does a firm maximize profits? By producing the quantity where the revenue generated by the last unit is equal to the cost of the last unit. And then they're going to charge the highest price people are willing and able to pay, go up to the demand curve for that information, hang a left, and P prime is the price for the monopolist. How much money are they making? Well, the average cost, go up to the average total cost curve, hang a left, AC prime is it. Price minus average total cost gives you the average profit per unit. How many units am I making? I'm making Q prime. And so that shaded area is what? What's that shaded area? Profit. So it's economic profit. Okay, so that's the standard monopoly model. Now, profit, profit, profit. What is this signaling to other entrepreneurs?
Enter the market.
Enter the market. But they come to enter it, and what do they get?
Monopoly.
Pushed away, a barrier, a broken arm, a dead family member, whatever. Sorry to bring up death like that on you. But they have some sort of barrier to entry. Maybe it's government. They have a patent and the government will bust them or something. So there's barriers to entry. So that's where our monopoly model ends, is that we'd expect positive profits. Now, the monopolistic competition model says, oh, we can enter, right? We can enter and gobble up. So maybe you were the first person to come up with a fast food hamburger. Thank you, Ray Kroc and McDonald's. But then there was no barriers to entry. And so now the average cost started to go up because all of a sudden McDonald's had to start advertising, right? And maybe some other cost involved with Hardee's being right across the street. So maybe their demand, it doesn't show it very much here, but it does show it a little bit. The demand for the McDonald's hamburger flattened a little bit and shrunk down. So if this was Mickey D's, now it's flattened and shrunk down. So the demand is less, my costs are up, and so through the competitive process, all of those profits are going to be eaten away. And so this is the long run equilibrium in monopolistic competition. How does the McDonald's maximize profits? They're still going to produce the quantity where the revenue generated by the last unit equals the cost of the last unit. That's Q star. They're going to charge the highest price people are willing and able to pay. That's P star. But now the average cost per burger has gone up such that each company is earning a normal profit or zero economic profit. Okay, questions there? That's basically a little principles review. All right. And I didn't catch your quadopolis. So this is with McDonald's, Burger King, Wendy's, and Hardee's. Right? The quadopolis. We don't really use that. That's kind of like it's a little obnoxious if we start. What is a sextopolis? What's an octopolis? We don't keep going like that usually. All right. So the equilibrium number of firms equals the market quantity divided by the quantity per firm. So again, this is something we would have done in the principles class also. There's the market quantity. Each firm is producing a certain amount, which gives you the number of firms that are producing the product. So big Q divided by little q is just kind of solving the model. All right, so the last comment here that the author throws up is using this context, how can we relate to the notion of monopolistic competition to a spatial context? So we just kind of did Principles 101, here's a monopolistic competition. But now some of the things we've been doing with ice cream on the beach and cities developing, what's your thoughts here on what that how that would relate to a spatial context?
Like in the ice cream example,
Okay?
the first vendor put 6, so then the other vendors do like the signal to entry and start going to 60.
Yeah. So where do we find Wendy's, Burger King, McDonald's here in Ottawa?
All next to each other.
They're all on top of each other, just like the model predicts, right? So because of that, with travel costs and whatever, that's the place to do. So we see a little bit there. Other thoughts come to mind on spatial context with that?
It might stifle growth if they push out competition too much. I mean, monopolistic competition, it's not like perfect competition.
Well, with the free entry and exit though, that's the main thing, the main assumption here. So in a spatial context, we're going to end up having transportation costs, like back to our martini glass or other things. So part of the cost is that, and that's why we'd see them maybe locate there, but for other reasons, they might locate in different areas, right? Okay, so let's see. Economies of scale. So how will the market support at least one firm if the market demand is large relative to economies of scale and production? So we got two things going on. What's happening with economies of scale? Something's going up, something's going down.
Oh,
Inputs and outputs, economies of scale.
Double our inputs, double our outputs.
No, that's returns to scale, which is a kissing cousin, to economies of scale. Yeah, what's the scale part? Let's start there. Is that quantity, or is it the number of firms, or is it the
Cost?
the number of GDP or something? Or
Is it production?
it's the production level, right? So it is the quantity. So as you increase the scale of production, the quantity being produced, as you increase the scale of production, economies of scale says what happens? Chat box. All three of you, I want an answer, even if it's a guess. Chat box. What happens?
The bigger you get,
The bigger you get, the harder you get, the faster you fall or something?
the long run average total cost goes down.
Good. So it's the total cost. How did we do on the chat box? Was anybody quick to the gun? I don't see any chats coming up here. Oh, there it is. Okay. Double the output. Okay, so Jacob, thank you for participating, even though you're wrong. Okay, so the double the output thing was the returns to scale. If I double all my inputs, do I double my output? Do I more than double my output? Do I less than double my output? So, all right, and Kaylin says the cheaper it gets, and so that's where I'd want to get more specific that it's long run average total cost, right? So that's the economies of scale thing. Now, so bigger is better in terms of increasing the scale of production. But how does that relate to the type of good it is? What kind of goods do we find in big cities, Kansas City versus Ottawa, Kansas? What are some things that Ottawa doesn't have?
A lot of clothing stores, really.
Okay, clothing stores. So do we have a Kohl's? No. We got Walmart, if you count that as a clothing store of some sort. But Kohl's kind of does everything too. But do we have any fancy boutique stores?
We used to.
Did we?
Maurice's.
Yeah, that's right. They had a satellite store that's not there anymore. Okay, what else? Kansas City versus Ottawa. There's 1,000 things.
Really fancy food places.
Okay, fancy food places, right? So high-end dining, maybe a Vietnamese place or a fancy swanky steak house that, you guys been to some of those that it's a a la carte menu, and so you order some sides and a $75 ribeye. We don't have that here in Ottawa. We got Smoke Creations. Okay, what else? What else is in Kansas City that's not here in little old Ottawa?
Art galleries?
Art galleries, good. So art galleries could be another thing. What else is in Kansas City that's not in Ottawa?
There's no venues.
Venues. So like Arrowhead Stadium is not located here in little old Ottawa, Kansas, for example. Go Chiefs. What else is in Kansas City that's not here? What else is like, you mentioned art gallery, but what about performing arts?
Concerts.
Concert venues, right? So we've got the Sprint Center, Kauffman Center, right, for different things. So we got a lot of different goods, restaurants, and all those specialty places, and you just have a lot of them too, right? So we might get one, but they've got 10 to pick from. All right, so that's kind of what we're thinking is, why do we get some stuff in some cities and not other stuff in others? And so it's a combination of this economies of scale, the degree to which you need economies of scale, and also the level of demand. So we're going to look at the kind of citywide demand, which we can think of on a per person basis, like the per capita demand. So how can we earn a profit in a relatively large setup cost? That answer is economies of scale. We got to do a bunch of them, right? So we're going to have to bring down our cost by having enough product sold. Now, if we're a venue, that's butts and seats, right? It's concert tickets sold or whatever. If it's a restaurant, again, it's butts and seats. And so how many times are we in Ottawa going to want to go to that $75 steakhouse? Well, let's see, last time I checked, average income in Ottawa versus average income in downtown Kansas City. So we got factors like income that could play a role as a part of this. But we might sweep some of that underneath the rug. It might just be that we just don't have enough people. We're going to need restaurants that are going to service the average Joe, right? We got our barbecue joints, we've got some of our fast food places, hamburgers, and maybe a pasta place and whatever. But the per capita demand is not there. If Ottawa doubled in population, then that would bring on new varieties and probably new things. Maybe we'd eventually get to a point where we'd have a higher end steakhouse or something, but maybe not until we got up to, I don't know what, there's a couple, actually Justin Clark worked at the place on Mass Street in Lawrence. Lawrence has about 90,000 to 100,000 people. It's like the numbers, 55, 655, 755. Anybody know, Kaylin, you're living up there, the kind of swanky place. I remember he wore like, or they wear, you know, the white and the black, and look all fancy. He was a bartender there. But fancy joints on Mass Street. Did you, Lawson, over the years, you never took a hot date up to Mass for prom or something?
Not there.
Not there?
Not that place.
I can't remember the neighborhood, but you guys get the picture. All right, so this is what they're struggling in. We got to have enough people to do it. Okay, so when we have low per capita demand, then we need a large population. So if the demand is low, if the per capita demand, like how many times do you guys use the opera? Right? How many of you have been to the opera? Okay, we got one at least, we got two, Tyler, okay, maybe you went on a field trip or something. But, you know, how many times do you go per year to that? A half a time? Maybe once every 2 years, once every 3 years, whatever, right? So it has a very low per capita demand in terms of how many times people are going to want to go compared to a barber. How many times are you guys getting your hair cut? 2 weeks, geez, you gotta keep it nice and trim, huh? With that, what do we call the soccer slide or the zero fade, the fade, right? Something like that. All right, so I'm about a 4 week, right? But all of us have kind of a higher per capita demand about the number of times we're gonna need to see that. So we don't see too big of a shortage here in Ottawa of haircut places. All right, other examples you can think of? Anything else? Difference, large city, small city, now that we're thinking, you can think things that are here, that are transportation. Yeah, Uber, that's a good one, yeah. Having There's just not enough per capita demand for Uber. That's why we don't have Uber. Some people have tried, and there's kind of been a makeshift Uber, I remember a couple years ago. Is there any entry? Is there a barrier to entry to running Uber here in Ottawa? No. No, if somebody wanted to do it, they do it. But the problem is they do it, and they're like, oh, I get one call every 3 days. This is not too profitable of a thing for me to be watching my phone. Or I give one ride, and of course the advantage of Uber is that you drop that person off, you look on your app, you accept another one, and you're just kind of continuously going. So if there's not enough per capita demand, then we're not gonna see that pop. All right, so this last figure is kind of just saying, holding constant some industry that looks like this, the small city doesn't have enough demand to make that good happen. The big city does. And so now we might have the same thing going on with our monopolistic competition, that it'll drive up average cost over time, we'll have entry and exit, but this at least kind of sets the picture that the per capita demand is high enough to be able to support that. Okay, questions or comments there? All right, so consumer cities. So we've talked about production. Large populations get goods with low per capita demand. And so there's a kind of a reinforcing thing that everybody has a different bundle of goods that they like, right? I work out a lot, which is obviously a lie. I'm getting this close to going back to the gym, but so I like bikes and trails, right? And I'm a runner, and I want trail system, and I like to fish, and I like the availability of the opera being there, right? So we all have different preferences, and so what's interesting is that when you start to have a couple together, their bundle of preferences may not look the same either, right? Most likely won't. Some of those couples that are all ooey gooey and like, oh, we gotta do everything together because whatever you like, I like, honey, right? And they kind of make you want to puke. But that's not real world. That would be, the real world would be, I have a bundle of things, you have a bundle of things, so we do a little Venn diagram, but the big city's gonna be meeting both of ours, right? A little bit easier. So, we tend to get more variety, and then people want to move to that. Okay, so the central place theory. How do cities develop? How do cities vary in size and the variety of consumer goods? So we got a little model we're going to work through, and I actually I'm going to take this backwards from the way the author did it. So this is where we end up, which is kind of similar to some of our ice cream stuff, but it's a little bit different. So imagine that we have a region of some sort, and they have 48,000 people, and the region starts off with 1,000 people distributed along the line. And so why would people tend to move to the middle? What things would be in the big central city? So this is the central place. And then what are the things that might be out on the fringes if we start with an equal population? All right, so that's kind of where we go to. So now let me go back. Whoops, that's a cool graph to get to here. I went the wrong direction. All right, so the model then has a bunch of assumptions that are, not so realistic. Fixed population, of course, populations change. Ubiquitous inputs, what's ubiquitous again? Always available, easy to get, basically cost-free to get it. So those inputs are there for businesses to start up. Uniform demand. So basically each one of these cities has people that have equal demand to them. Perfect substitutes. So Joe's barbershop and Sally's barbershop, it's a perfect substitute. You don't care which one you go to, right? So all of the companies have identical goods, and then no complementarity between goods. So the barber shop goes really good to the restaurant I love, and so I go get my hair cut and I get a coffee or something, right? So no relationship between the goods. All right, so now we've got these these assumptions and the 48,000 people. And where are they going to go? Okay, so now the author kind of just walks you through the per capita demand bit. So clothing store, the Kohl's or the fancy designer shop or whatever in the downtown. So per capita demand is low relative to economies of scale. So no single firm would want to open it up with just 1,000 there, right? Now, we've got the median location thing going, so that if there is a clothing store, people would travel to it, and so where would it locate? In the middle. So our clothing store, given that region and people being willing to travel, we'd end up getting the clothing store there. When the clothing store gets in, we start to see some other things that we've been looking at, increasing density, so people maybe start to move, some of the workers bid up the land, and away we go. So then the grocery store, we've got a medium, so the author just kind of goes low, medium, and then high. And so it's saying 4 firms come in, and again, this could be done with a bunch of math and do it a little differently, but he's just kind of illustrating. So then we have enough for 2 grocery stores, right? So we can't put a grocery store in every single city because the relative economies of scale to demand is that. All right, and then we got the barber shop. So we can have 16 firms because everybody needs a haircut. And so there's going to be places at each grocery store has enough to demand 2 barbers. The remaining 8 barbers generate 8 barbershop cities. And that's what brings us to this. So we've got barbershops here, and then what's the other thing? So we had clothing stores, barbershops, and grocery stores. So what's in this city? Barbershop. What's in this city?
Barber and grocery.
Barber and grocery. And then we're back to barber, according to there's enough demand that there was a barber in every single place. But then here at the center, we're going to have barbershops, clothing store, and grocery stores at the dense part. And then we'll have the breakdown the rest of the way. Okay, so the cool graph is this one. This is where I'll leave you and we'll pick up tomorrow. There's not much more to this chapter, but I'll say a few things tomorrow. But this is Real World Indiana in 2014. And so they do some cool things of looking at the industries and where they locate. And so you kind of see the distribution of the distance, and that kind of supports this idea that you get some things, the opera and Arrowhead Stadium or whatever is all here, but there's also some other ones located here, the grocery stores, and then you've got the smaller parts. So they can kind of observe whether this thing really works or not. We'll pick up there tomorrow.